With more than 60 scientific publications and over 12,000 citations, he is a designated expert in the fields of data analytics and data science. Please welcome Sebastian Mika.
Well, so you might see the title of my presentation, NLP really from scratch. That's pretty catchy. And well, I mean, it actually starts with the word NLP. And we've heard quite a bit of NLP today. And I mean, there was a really good panel discussion here. And well, you could guess that what we heard today, that NLP maybe is more or less a solved problem. So you take some data, throw some deep learning at it, and you're set. So, well, if that was true, then I probably wouldn't be here. So maybe there's more to it. So how does it work? So what I'll be talking about is the specific challenges that we faced at Comtravo when we try to, well, actually use NLP. And I will specifically concentrate on challenges that probably other startups would also have that try to actually make use of text data. And well, I mean, it all starts with that what you don't want to do as a startup is to produce a research paper, right? I mean, it's not about a benchmark data set and being like 0.1% better than someone else, but it's actually about making something work in practice. And yeah, so what's that challenge we actually try to solve? It is to try making business travel radically simple. And the idea is that business travelers basically just drop us one message, like an email, and then that's all they need to do. So, okay, of course they need to confirm at some point that they want to pay, but that's really all. And we focus only on business travel in companies, and this will be, it's not just a nifty detail here, but we see why that is important to make NLP actually work. And yeah, why is that actually interesting? So business travel, well, the industry is actually quite broke, you could argue. So it's dominated by really large companies, which are really old, say like Amex, BCD Travel, Carlson, Wagenlied. They billions of revenues and cohorts of travel agents, like tens of thousands of travel agents. And what they offer you is, well, of course, hotlines, very complex self-booking tools, and then they have mind-boggling tariff structures. And, well, it's anything but not radically simple. So, and maybe it could look like this. So what's needed to be radically simple and at the same time still make money, obviously. So clearly not legions of travel agents, but rather some end-to-end automation of the whole process. And, well, it starts with an incoming request. So someone sends a message and says, I need a flight. And then in the end, he gets his offers, his bookings, maintenance during travel, so you're delayed, whatever. And, well, that's now where we come back to the NLP from the title. What I will talk about today is the very beginning of that journey. So if you want to automate, you obviously have to understand what the people actually asked for. Well, the rest of this is also non-trivial, right? I mean, it seems trivial if you try to book your trip on like a B2C website. It's just some simple form. You fill it in, click, 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 you got your ticket. But if you try to do that as a travel agency, this looks much different. And one reason for that is that the IT landscape in travel, well, most of it somehow stopped developing somewhere in the 90s. So if you're into XML, then that's the place to go. But yeah, probably not. So let's get a bit more concrete. So this is just a simple travel request. Oh, I need a flight, blah, blah, blah. And what you see on the right is probably familiar to some of you. It highlights the relevant entities in this text. So like persons, times, locations. And, well, it looks quite trivial. Probably not trivial for a machine, but trivial for a human. And, of course, this can get more detailed, and there's more text, there's more entities, there are more potential relations between these entities. And, well, we can continue that for a while now. It can get very detailed and have many texts, many text pieces, many entities, and yeah, sometimes it's also annoying. So some people are especially clever, they send screenshots, and unless you also want to tackle OCR, then, well, that's at least difficult to solve, but sometimes it's also funny. So, and even though we limit ourselves to business travel, there's basically no limit to the creativity of our customers. So how did we attack this creativity? Of course, we could have said, let's get rid of creative customers, but then we would have less fun and less customers. So we did what any data-driven company would do. We tried to identify potentially simpler subproblems. And luckily, the simpler subproblems are also the most prevalent problems. That is, like, very shortly, most of the requests we get are really just for one-way or return flights or hotel bookings. That can still be complex, but it's not as complex as a 60-people group booking where they fly in from 20 locations, need helicopter transfers, and can only stay on the 13th floor of some hotel. So let's dive even more into the actual challenge. So again, we're given a text, I need a flight on the 28th to Nuremberg, and so what do we need to do? Well, first, of course, we need to find the entities. So what are actually the, in a way, atomic building blocks in that message? So here, dates and locations. Then we probably should assign them to some slots. So we need to say, okay, which of the locations is actually the destination in that flight, which goes into the departure time. And you can already see here, even though it's extremely simple, it's not a one-to-one relation anymore. So information might be spread across the text, and then you need to figure out how to put that in the right slots. Well, once we have the things in the slots, we should probably assign meaning to it. And in this case, it's quite straightforward. So Nuremberg, like if you want to book a flight, you have to find the IATA code. It's a 3-letter abbreviation, and that's NUE. But now imagine someone sends a message and says, I need a flight with South African to JHB, which is also a IATA code, but so he probably wants to fly to Johannesburg, but JHB is actually Singapore. How do you deal with that? But luckily, of course, we have a customer context. And I mean, in that case, for example, there was no origin. It didn't say he wants to fly from Berlin, for example, to Nuremberg, but we might know that this person is at that very day in Berlin because he booked another flight there, or we might know that his office is in Berlin. And then, of course, there might be other information like cost centers we can pull from some other data source. So, wonderful. And we're set, right? Just go and train a network, but, well, on what data, right? So Comtravo is about 2 years old now, which is probably older than many startups get, but it's not a lot of time to collect data. And one thing is to have the texts, but then the other thing is that you actually need to annotate it. And so when we started like 1.5 years ago to model this problem, we had like 3,000 messages. There's not a lot you can do with that. And then, of course, there's a lot of stuff going on in machine learning, and especially in NLP with deep neural networks, and they have wonderful benchmarks and everything is wonderful. But if you look at the typical data set sizes they use, it's rather in the millions, right? So we had to come up with something else. But then NLP is probably more than just deep learning, right? There's recently been some interesting discussion between Yann LeCun, who's basically the godfather of deep learning, and Yoav Goldberg, a pretty well-known linguist or computational linguist. And, well, they had a quarrel about whether it's actually fair to claim that you solved an NLP problem using a deep learning machinery if you don't really understand what the deep learning machinery does. But, I mean, that's a different discussion, but there is more to NLP, right? And now that's actually where it becomes important that we operate in a very limited domain here. We only do business travel, and then in this business travel you have a lot of repetitive patterns, obviously. So there are city names, there are very common keywords, from, to, for, at, before, after. There are a lot of gazetteers, like collections of information you can use. I mean, it's easy to get a collection of all airlines, cities, whatever. And, well, that doesn't solve the problem, but makes it a lot easier to attack. So how did we get our data? So, I mean, luckily on the side, we operate a fully functional travel agency, which actually has customers and just generates data. And then we went to an extremely painful annotation exercise, and we still do, but it's worthwhile doing it. It's probably one of the biggest assets we have right now. I guess Andrew N. recently, he put it in I think it was in Harvard Business Review, he said something like that AI teams among companies can probably easily copy each other's software within 1 or 2 years, but the actual barrier is getting access to data. So data is what limits you in doing interesting stuff. So well, then now we're set. So we got training data probably. So you got a text, still the same one. We got labels for each word. We know in which slots they belong. And then because we sent an offer, we also have a structured representation of what we want to achieve in the end. Yeah. Well, I mean, obviously, some scikit-learn and the Coursera course are not enough to solve that problem, but it's even worse, right? And I remember from that panel discussion, someone was mentioning that it's actually quite difficult to measure success, and that's also true here. I mean, how would you define a loss function on that JSON structure? So it's difficult, believe me. So how we solved it is, well, we set up a pipeline which does it in steps. That's actually, I once learned from some pretty famous guy from statistics. He said to me, if you have to solve a problem, really solve your problem, and don't try to solve intermediate problems, but, well, sometimes even the big guys might be wrong. So and what we do is basically this. So we start with a tokenizer, simple as that, but then already here the problems start. I mean, you can try to use Spacy, for example, or core NLP, or something like NLTK from Python, and it's gorgeous tools, but they fail completely on our messages. So what we rather did is we wrote our own tokenizer, which is domain-specific. It already knows which are typical patterns you want to find. I mean, think of Yata codes, like these three uppercase letters are a token for us, and that's not always the case for other tokenizers. Well, then we go and find the entities, and we do that with a conditional random field, and there was also a discussion here about whether it's actually cool to use deep learning because then you don't have to do feature engineering. Here we did feature engineering, so it's like 17,000 features or something, or even more probably, that are in the CRF, but well, it works quite well. Amazingly, it does not work much better than using a set of regular expressions. So that's what we actually started with in the beginning. But then, like, if your set of regular expressions grows to like 500, the CRF is definitely easier to maintain. Well, okay, once we got the entities, as I said, we find the slots, and then, ta-ta, we also do deep learning. So this is like a recurrent bidirectional neural network with millions of parameters, and honestly, we have no idea why it works, which is nice. We don't have to care, but it's also a problem because it's hard to reason about the cases where it doesn't work. And well, and then that's basically it already. The rest is more or less software engineering, so like getting the semantics right, parsing the times, and that's not so easy probably, but it's doable. And well, in the end, as in most machine learning pipelines, there's some post-processing, and there's also some secret sauce here where we correct for errors. And obviously, we do errors here. Well, but how well does it actually work? So this shows the performance on the main entities we have to find, and well, the precision recall. So it basically means that for locations, if you say something is a location, that's true in 92% of the cases. And we find about 88% of the locations that are in the text. And if you compare that to, well, benchmark tasks for entity detection, that's actually quite good, especially if you consider that this is done on 28,000 documents and not 4.5 million documents. And if you consider that, like, the standard, like onto nodes or whatever benchmarks in NLP, they usually look for maybe 7 or 8 entities. Here we look for 25 different types of entities. So we're happy with that. But yeah, obviously, so it's nice to find the single entities, but if you get just one entity wrong, this might spoil everything, right? So think again, like we send someone to Singapore instead of Johannesburg, probably that person will not be our customer anymore. So how does it look if you go up one level to the slots? well, the performance obviously is slightly worse, but it's still quite good. So this shows, like, if you take the first line, that's performance numbers for how well do we detect origins in flight requests, and, well, we get them right in 80% of the cases. Well, then in 7% of the cases, well, we send people to the wrong, or actually, let's take the destination, that's easier. In 7% of the cases, we send them to the wrong destination. Well, in 10% of the cases, we just don't find it. And then that's probably the most annoying bit. In 3% of the cases, we even find a destination that has never been asked for. So if you book with Comtravo, expect to get more than you actually asked for. But again, of course, this is on single slots, so the overall performance is not as good. But overall, like if you look at this limited domain that I said, like these flight and hotel requests, we already get everything right in more than 50% of the cases with very limited data and actually limited time. So we do that for 1.5 years, and we don't have 200 data scientists. It's just a team of 4. So where are we at now? What we do, it's a machine-human hybrid. I could have said human-machine hybrid, but actually it's rather that way around. So there is the machine, which gets many of the requests right, and then there are our agents on the other side, which basically take over the complex cases. And there was an argument here, I don't know what that guy's name was, but I fully agree with that. On the one hand, it might be frightening that machines take over more and more work that humans do, but on the other hand, like booking a ticket for a really trivial request, like book me a flight from Berlin to Nuremberg on that date, no one wants to do that. You know? It's much more interesting to book complex stuff. So on the other hand, what these agents do, they constantly generate new data. With every booking we do, we get more data and more data and more data, and probably getting more data will not solve all our problems, but it will definitely help us to improve our performance. Well, for the end, I'd like you to meet Sophia. And I mean, Sophia, that's admittedly a pretty stupid working title of our intelligent machinery. And this young lady here happens to be the niece of our lead architect. And, well, I mean, she's obviously quite young. But I don't know, I mean, if you got kids, like this lady is about 6 years old. The Sophia that we developed is on a very high level already. And I mean, what she does basically is for the things she can handle, this reduces the agent time to 0. So there's no human involvement anymore. And also, I mean, it's nice for the customers, right? If you send that message or if you call this hotline at the travel agency, it takes like 10 minutes, half an hour before you get your ticket. Here, it's just a matter of minutes to get your ticket. Well, and maybe one of the core messages is, I mean, NLP is tremendously difficult, but if you limit yourself to a well-defined domain, and if you find a good balance between using fancy stuff, which probably attracts intelligent people, but also using really rudimentary old-school shit, it's not such a big challenge, actually, to get things running. And that's about it. Thank you.